Oh, yep. Here comes a big one. Miguel, watch and learn, buddy. Yep. Real fighter, you know?
Are you tired of your fish looking like this, or even this? Well, I can tell you Teck Resources Limited isn't. Their coal mines in the Elk Valley have single-handedly contributed to the Elk River being one of the world's most polluted rivers due to mining causes. The river was reported to have over 100 times the regulatory selenium concentration, which resulted in a 93% decrease in the valley's fish population, leading to huge pollution in the valley's drinking water. With that information, you could say that there's a need to find a way to address water and sediment contamination in the Elk River region caused by coal mining activities that ensures the health of aquatic ecosystems and public and nearby communities. Now, we saw this issue and knew someone had to solve it. No, we had to solve it.
Hi, I'm Owen Chiu, and I'm the civil engineer of this project.
My name is Ansh Chug, and I'm the environmental engineer for this project.
My name is Vladanilo, and I'm the electrical engineer for this project.
I'm Jace Engineering Gordon, and I'm the project manager.
I'm Leo Huang, and I'm the operation and logistic lead.
And after countless hours of rigorous ideation and brainstorming, we came up with the pinnacle of what modern science is truly capable of. We call it the battery bridge.
Alright, let me walk you guys through what goes on inside the design. Moving over here, the water will flow through a staircase-like structure in which at the very beginning there will be turbines which generate hydroelectricity. This hydroelectricity will be used to power these electrodes which are stacked, just as shown in this diagram right here. This high level of electricity will create a reduction oxidation reaction which will form a precipitate with the selenium ions. Then, those selenium ion precipitates will be filtered through these membrane filters, letting the water flow through.
To test if our design worked, we made various low fidelity and medium fidelity prototypes. Our medium fidelity prototype tested whether the process of electrocoagulation could be fast enough for a design to work, and so we developed a simple experiment using a small Tupperware container, 4 electrodes, and 2 9-volt batteries. And after various tests, we concluded that it should probably work. However, the process was a lot slower than we anticipated, and because of this, we decided to rework our design to include more electrodes and more chambers.
Alright guys, let me run through our cost-benefit analysis here real quick. So for the initial facility cost, we arrived at the conclusion that it would take around 4.5 to 5 kilowatt hours per cubic meters of water treated, and Elk Valley has an average yearly flow rate of around 35.66 cubic meters per second. Doing these calculations here, that means the facility needs to be around 610,000 kilowatts. Multiplying up the average dollar value per kilowatt, the initial construction cost will be around $2.4 billion. For each of these metrics here, per cubic meters of water treated, we arrive at these dollar values using literature. With the application of the present value factor, with an I of 10%, an N of 3 years for construction, and an N of 50 years for maintenance, we arrive at these dollar costs per year for each of the same metrics. Running through the timeline, that means that the average profit per year would be around $479 million in environmental benefits. The total profit after 50 years is $17.87 billion, and it's like around 12.73 years to break even.
At the current stage, we face several limitations regarding our project. Due to the scale of our project, the project management aspect will be complex and potentially leading to project delays, budget overruns, and a lack of stakeholders willing to join in. The conditions of Elk Valley, including the fast flow rate of the Elk River and the cold temperatures during the winter, may also be challenging for our design to reach its final objectives. On top of that, the scale of the construction may also cause significant impact to its surroundings, causing more harm to the environment than the benefit it brings.
Luckily, we have solutions. To handle the complex project management, we will construct a detailed project timeline and critical path analysis to prevent delays. In addition, we will consider multiple suppliers and contractors to mitigate budget overruns. Moreover, we will host regular meetings with all parties, including local representatives, to ensure their needs are met.
To ensure the function and effectiveness of the final design, procedures like conducting in-depth experiments using computer-aided software and constructing a small-scale prototype at Elk Valley will be used to verify the design before the final construction. Multiple materials for the electrodes will be tested to maximize both the durability and the efficiency. And lengthy testing at cold temperatures will be conducted to ensure effective operation even during the cold winter.